Hello guys, in this video we will be solving the Leetcode problem 118 Pascal's triangle. So without wasting any time, let us get started. So let us first understand what exactly the Pascal's triangle is. For example, if they are giving the number of rows as 5, we have to generate a triangle in this format. For example, 1, 2, 3, 4 and 5. So this Pascal's triangle is having 5 rows. This particular height of the triangle is considered to be the number of rows. Each is going to be consisting of one row. This is going to be like the row 5 and this is going to be like the row 1. So if they are giving 5, we have to generate 5 rows, and if they are giving 3, we have to generate 3 rows and things like that. So this is the problem statement which they have given. And how exactly this particular numbers are formed is what we are going to consider. For example, the row 1 is always going to be 1, and then the row 2 is going to be having 2 columns, and 3 is going to be having 3 columns, 4 is going to be having 4 columns, and so on. So the first row is always going to be 1, so we don't have to worry about it. The next rows, column 1 is going to be having the sum of two different sides of the triangle. For example, let us assume this is the triangle, and this is going to be having the sum of the right side and the sum of the left side. So in right side there is 1, but in left side there is no element here. So we are just going to add these two things and put 1 here because there is no element here. And same goes for the left triangle. If you consider this triangle, and in the left side there is 1, but in the right side there is none, so we are just going to add here. And similarly this triangle also applies the same, and this triangle also applies the same because there is no element in right side, there is no element in left side, so we are just putting 1. Let us but if we consider in the middle triangle, if you just consider in the middle triangle, you can see, in the left side there is 1 and in the right side there is 1. So we are just going to add 1 plus 1 and put 2 here in the middle. So the result is going to be 2 here. So if you consider this particular triangle, there is 1 in the left and there is 2 in the right. So it is going to be 3, and there is 2 in the left and there is 1 in the right. So this is going to be 3. If you consider this, you can see 3, 3, 1. So this is something which this is the pattern which we have to generate the Pascal's triangle. So I hope you understand the concept which they are trying to explain. But how exactly can we do this programmatically? Because if we access the elements in the left and right in an array, let us say we have created an array for each row. Let us say we have a row here, and this is going to be an array. But if we access the left and right where there are no element, we will be getting index out of bounds exception, maybe if you are using Java, or index error in Python. So what exactly can we do in this particular case? This particular solution has been inspired from Leetcode, but I have modified it slightly to add memoization to support additional to compute the overlapping subproblems. So what we are going to do is, what can you, maybe I'll give you a 10 second, you can think and tell what exactly can we do here in this particular solution. Because for example, if we access the element which are outside the 0, there is no -1 and there is no 1 in the index of the array, so it will obviously throw index out of bounds exception or index error. So what we can do in this particular case is we can convert the previous row as an array. Let us say we already have an array of 1 here. What we can do is we can pad 0 on left and right of the array, and we can simply pad zeros for the left and right, and we can make an array like this. So 0, 1, 0. So if you add, so this already has 0 here, this has 0 here. So let us just use the eraser, and I don't know how to increase the size of an eraser, but let us just erase this particular one. I have Paint is a thing which took me, Paint is the first program which I learned in my childhood, and so now it is 0, 1 and 0. So here if you consider in the left there is 0 and right there is 1. So 0 plus 1, 1 and 1 plus 0, 1. So we can build the Pascal's triangle like this. So without wasting any time, let us get started in the program. I am going to use recursion, a recursive solution obviously, so that it can solve itself, and I'm going to add a bit of memoization, and thanks Leetcode for providing this inspirational way to add zeros in left and right. So let us get started there. So I'm not going to use the same one. I'm going to create a new function, def generate triangle self. I'm going to have the result. The resulting triangle is obviously going to be an array of array, which is list of lists. So I'm going to have a result, and I'm going to have obviously the number of rows which needs to be generated. We can place it in the instance variable, but anyways let us place it in the recursion itself, and then the current index, the current row which we are working on. For example, we are working on the row 0, we are working on row 1 and things like that. So this index is always going to be pointing at the last row, so which we have worked on. For example, if we have generated the triangle at index 0, I am going to erase everything. If we have already generated this particular one, the index is going to be pointing 0, so that we can take the next one and the next one and next one and work on it. So index is just the number of rows, current row which we are working on actually, and then it identifies the next row. So I am going to say if len of result is double equals to n, return the result. So since we are using recursion, we'll work on to multiple levels. We'll keep on incrementing. If the length is matched, we'll be simply returning the result. And let us say and we'll generate the triangle here. We'll return self dot generate triangle, and obviously the first row is always going to be 1, and we are going to pass num rows, and the current index which we are working on is 0. So we'll simply return the result for now and see if everything is going fine. I'm just going to return it, and obviously we'll get the wrong answer, but for the case 1 we'll get right answer, because it is returning the rows. So we are going to work on this particular function. So this index will always hold the previous row. So we have already generated one row, so index is always going to be holding the previous row. So now we are going to slightly modify the previous row. If we print the result of index, and I'm going to run this, it is going to be returning 1. It is going to return 1 because the first row is only the we have constructed, but there is no left and right of the for the row number 1. There is no left element, there is no right element. So we are just going to add zeros from to the left and zeros to the right. So we are just going to have previous row is equal to 0 plus result of index plus 0. So now if we print the previous row, we'll see there is left and right is now 0. So now all we have to do is construct the next row. So we have to use a sliding window pattern is what I am planning to use, a slightly modified sliding window pattern. We are going to take every 2 elements here. We are going to split the row into every 3 elements. For example, I am going to altogether erase everything. Let us assume we are working on the row 1 and we have converted our row into 0, 1, 0, and now we have to split the batch into two size of windows. For example, we have to split it into 0, 1 and the next one is 1, 0. So if we are working on this particular one, 0, 1, 3, 1, 0, then 0, 1 is 1, 1 and 1, 3 is one window and 3, 1 is one window and 4, 1, 0 is one window. So we are going to split it in that fashion. So we can just add the two rows. For example, if we have this 0, 1, 0, if we split into these two things, we can just add 0, 1 and make 1 and add 1, 0 and make the other column. So simply we can consider this. So we are going to have a slightly modified version of sliding window. We can also do this in 2 pointer. I'm going to do a slightly modified version of sliding window. The window is going to be this, and the right pointer is going to be initially at 0. There is no need for left pointer. We can simply consider the window size while right less than of 0. We are going to work on considering the elements. Window len of window, we are just going to split the rows into two elements, two batches of 2, not equals to 2. We are going to append the value to the window dot append row of right, and we are going to increment the right by 1, else we can do something else. Else we have to revert the size of window is equal to we have to empty the window, because after the windows added into this, we have to empty the window and we have to keep the new row, right? This is going to be our next row. Next row is going to be this. So we have to add row dot append window and or minus equals to 1. We have to bring the right pointer to one step back. For example, if you are working on the 1, 0, 1, 0, right is less than the previous row. After this, it will come, it will add this 2 in the window. If you see in this particular section, it will add this in the window and it will already increment to 1. So right will now hold the value 2. So we have to reduce 1 to bring it one step back so that we can add the other 2. So this is how we do it. Now if you print the row, let us just print the row and see what exactly happens. And always there is going to be one additional window left after this iteration. So we are just going to add that. Okay. I think I missed a V here. So if you can see, for the first one we can clearly see 0 comma 1, 1 comma 0, because we are going to say 0 comma 1 and then 1 comma 0. So we now have a value which is properly added. Now we will create a function which memoizes this value. Now instead of adding 0 comma 1 and 1 comma 0, we can simply add the 2 and consider the result, and add the row to the result directly, so without complicating further. So we'll create a memory, and then this memory is going to be, if you learned about dynamic programming and overlapping subproblems, you'll know the concept of memoization. So I'm going to have a memory, and I'm going to have a function memo, def memo, and it is just going to take our window, and it is going to hash our window. We are just going to hash the window to string, and if hash not in memory of hash is going to be window of 0 plus window of 1, because for example, if you have already solved 0 comma 1 is equals to 1, let us say they are giving like 10,000 rows. These subproblems will be constantly repeating, and we don't have to perform a lot of arithmetic operations here. We'll simply store this in a memory and retrieve it back. I'm just going to take it like a hash map. In the Python's case, it is dictionary. So we'll memorize this result so that we can use it. This avoids a lot of computation here, and that is what I'm trying to do. And I'm just going to return memory of h. So we have the memo function. Now we'll just, instead of appending the window, we'll append the memo of window, and row dot append memo of window. Now if we execute the program, we'll see what happens. Memory is not defined. Obviously, yes. We have to put self because we are accessing the instance variable. And here in the std out, we can see the next row is 1 comma 1. So we can simply append the result dot append row. Instead of adding the result, we can index plus equals to 1. We can return the generate triangle function, generate triangle, and we'll add the result. We'll put 10, and because now we are working on the next index, we are just incrementing it. Let us now run and see what is the output. Okay, I missed an append here. Now both our solutions are accepted, and if you watch the runtime closely, it is 0 millisecond. And let us submit the code. Let us see what is happening, and you can look at the magic. We have beaten 100% of other programmers, like we always do. So if you like the solution, please like, share, and subscribe. And thank you for watching.